So hey guys, how are you? Hope you're doing great. So in our previous lecture we have discussed the probability introduction to the probability. I hope you loved that lecture. So today we're going to discuss the terminology. So I just want you to familiar with these terminologies so that it will be easy to teach further lectures in the machine learning. Also we just use this terminology. If you don't know that terminology, so it will be hard for me to teach you out. So I just want you to be familiar with the terminologies. So I'm just starting with the terminologies in the if you don't understand also it's totally alright because we are just dealing with the terminology. So I just want to explain in a detail in a machine learning course. Okay, so for the first, which is the sample space. So what do you mean by this sample space? Means like it is a set of all possible outcomes of an experiment. It is denoted by, it means like it is a set of all possible outcomes of an experiment. Means like we have a dice over there, and just we just simply roll that out, and the outcomes, what are the all possible outcomes? It may be like 1 2 3 4 5 and 6. These are the all possible outcomes, right? So this is a sample space. I hope you're understanding. Like, so all the possible outcomes, it may be like 1 2 3 4. Means like other than this they cannot have another, like there the dice cannot have 7, the dice cannot have 9, right? So this is the sample space. Means like having all the output, right? Set of all possible outcomes. Okay, so this is a sample space, and then it is denoted by this symbol. This is denoted by this symbol. Okay, just remember this symbol. Okay, so for example experimenting on a tossing of a coin. So we just tossing a coin, and the sample space of this experiment. So we are tossing a coin, it may be like a head or tail, and other than that there is no choice, right? There is no choice, like other than that it may be like head or tail. We have only two outputs, right? So the sample space is equal to t and h. Means like the tails and the heads. I hope you having a basic understanding like what is sample space. The sample space is nothing but like set of all possible outcomes. It may have 10 outcomes, it may have 20 outcomes, but these all the set of outcomes is called as a sample space. Okay, I hope you understanding this. So after completing the sample space, we have something known as events. So what are events? So event is an outcome or a defined collection of outcomes of an experiment. Means like an event is an outcome of an experiment. So this is an outcome, right? So if I toss a coin, it gives a heads. This is an event. If it gives tails, this is an event. Means like an outcome of an experiment. The outcome may be the heads, the outcome may be the tails. So this is a event. Okay, so it is a subset of a sample space. Means like this is a sample space, right? This is a subset of, means it may be have a tail or head, the outcome may be the tail or head. So this is a subset of this sample space. I hope you understanding. Like, so we have group, like we have a tails and head, and this the result may be the tails or the result may be the heads. It's just a subset of this sample space. The sample space means nothing but the set of all possible outcomes, right? So I just want to give an example. So the determination of a gender, that is some determination of a gender, which is like a girl or a boy, right? So girl or a boy, so the probability of a girl is equal to 0.5, and the probability of a boy which is equal to 0.5, which means a 50% chance of getting a boy or a girl from picking out in a group, right? So there is a 50% of chance being a boy or a girl from picking the group. So it may be like a girl or it may be like a boy. So these are the events of that outcome, these are the events of that experiment. Okay, I hope you're having a basic intuition about what is events and what are the sample space and how these are related. So it means like the event is nothing but it is a subset of the sample space. Sample space is set of all possible outcomes, and this is the output, which is our event, right? I hope you understanding that. I hope you understand that. So after that completing these two, we have a degree of belief. So what do you mean by this degree of belief? So it refers to a personal belief or a confidence that an individual has an in occurrence of a certain event. Means like it refers to It refers to a personal belief or a confidence that an individual has an occurrence and a certain events. Means like it is a way of expressing the uncertainty about an outcome of an event and can be expressed using a probability scale such as decimal between 0 to 1 and other scales such as verbal and numerical. Means like degree of belief means like this is a kind of a personal belief. This is a kind of a personal belief that the individual believes that this might be a true, right? This might be a true or this might be a false. So I just want to give an example so that it will be easy for you. So if a doctor analyzes a patient and says that the patient has a 40% of chance having a cancer, means like the absolute uncertainty means like 1, which is 100% sure that the person have a cancer, right? And the 0, which is absolute uncertainty, means like the 100%, there is a 100% chance that the person don't have a cancer, right? So if a doctor tests the patient, if the doctor tests the patient and he says like 2 events, like it may be like a cancer, it may be like a non-cancer. If 40% chance having a cancer, means like 60% of a chance having a not cancer. I hope you having understanding like what I'm saying. Okay. So degree of belief means like it refers to a personal belief or confidence that the interval has occurrence in a certain event. Means like we are 40% confident. We are 40% confident that the person having a cancer, and we are 60% confident that the person is not having the cancer. I hope you understanding that. So after that we have a probability axioms. So what do you mean by these probability axioms? Right. So the probability axioms are nothing but are the set of mathematical rules that are defined properties of a probability. Means like these are the kind of assumptions that the people will believe that this is true. These are the universally accepted. Means like these are the kind of rules that everyone believe that these are the true. Okay. The sun rises in the east. This is the universally accepted, right? So these are the kind of axioms. I hope you having a basic understanding like what are the axioms, and these relate to the probability. So like how these related to the probability, like the probability axioms are the set of mathematical rules that defines the properties of a probability, providing a framework and manipulating the probabilities in a constant and a logistic way. Means like these axioms means like the probability axioms explains that these are the set of rules that are all expected by the humans. I hope you having a basic understanding about all these axioms and etc. So the most commonly used probability axioms are non-negativity and normalization and additivity and infinite additivity and the countable additivity. So the axioms means like these are the assumptions. Have you means like I just want you to cover in a linear regression and a logistic regression lectures like what are the assumptions. Means like assumptions means like we have to satisfy all these, we have to accept all these in order to get this probability. I hope you having a basic intuition about what are the axioms. These are universally accepted. If they are rejected, then we cannot continue with this probability. Okay, so the first thing, which is a non-negativity. So the probability of any event must be a non-negative number. Means like the probability is between 0 to 1. It cannot be like -1 or -2 because there is no chance of getting. So the probability must be like 0 to 1, right? So representing an impossible event and 1 representing a certain event. Means like 0 representing the impossible event. Means like 100% sure that it will not occur, and the 1 means 100% sure that it will occur. Okay, so there is a probability of A which is 0, which is greater than or equal to P of A, which is greater than equal to less than equal to 1. Means like it must be a greater than equal to, must be greater than equal to and the less than or equal to 1. I hope you having the idea like what is going to be. And the probability cannot be negative. So why it cannot be negative? Because we cannot have a negative probability. Means we cannot say like -20% chance of getting like this. You have a 0% and we have 100%. That's it. We are not saying like -20%. What the heck this is, right? So after that we have a normalization. So what do you mean by a normalization? So the probability of all these possible outcomes in a given sample space must be add up to 1. This is known as the law of total probability. So means like I just want you to give an example. Like, so we have a sample space, right, which is the probability of a sample space which is equal to 1. This must be equal to 1 because means like, for example, we are tossing a coin. Okay, so we just want to toss a coin. And this is an event occur in an experiment. Okay, so we have a probability of A union B, means like the probability of means like head, and the probability of getting tail, which is equal to 0.5 plus 0.5, which is equal to 1. Yes, it's saying like a normalization which is equal to someone must add be equal to 1. I hope you're having a basic understanding. So, and I just want to give another example. Like, we are rolling a dice. And the probability of all that is equal to 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6 and plus 1 by 6, right? So these are the 6, and the outcome will be like 6 by 6, which is equal to 1, right? I hope you're having a basic intuition about this normalization. With the normalization of all possible outcomes in a given sample space, we in a given sample space, which is are equal to 1, right? I hope you are understanding this. This is a law of total probability. Okay, so after that we have additivity. So what do you mean by this additivity? So the probability of union of two mutually exclusive events. So the probability of union of two mutually exclusive events is the sum of all probabilities of each individual event. Means like, what is saying, like, if I have a and B are the two disjoint events, means like they are independent to each other, then the probability of their union satisfies like this is equal to P of A union B is equal to P of A plus P of B, right? So hence here the both are independent, which means like they cannot occur at the same time. Means like tossing a coin, it may have a head or a tail, it cannot occur both at a time. I hope you having I hope you understand that it may occur like a head or a tail, means like it cannot occur both, right? So for example, if a sample space has a finite number of elements, means like 1 2 3 4 5 6 and so on, number of elements in a sequence of a disjoint event means what? They are independent to each other, and the probability of their union is what is P of 1, means I have taken a A1, so just go with the A1, and we have union A3 and etc., and this will equal to the P of A1 plus P of A2, P of A2 plus P of A3, and so on up to P of AN. So n is number of elements we are having in this event, in this experiment. Okay, so I just want to explain it once again. Like, so what do you mean by additivity? Means like the probability of union means what? This is a symbol. I hope you have a understanding of, I hope you have a basic intuition about the union and intersection. If not, as then please comment down below. So I just want to make another video. Okay, so this is a union, this is the intersection. I hope so I just want you to know. If don't know, then please go and research about that and come back, so that it will be easy for you. So this is a union means what? We just simply add these two, right? So means like union means like these are these, and this intersection means like this attached part. So I just want you to research, so it will be easy for you. Okay, don't worry. So the probability of union of two mutually exclusive events in the sum of all probability in the individual event, means like we are adding these two events. That's it. There is nothing special about this, and this is additivity. So after that we have a finite additivity. We have two kind of additivities. We have a finite additivities and countable additivities. So what is the finite additivity? So by the word you can understand the finite, which means like if an event can be broken down into finite number of that are mutually exclusive sub events, then the probability of any sum of the, so all this blah blah blah, just it is have a into a finite number of mutually exclusive sub events. And the countable means like it broken into the countable number of mutually exclusive events, means the countable means like 1 2 3 4 and 5, and these are the finite number of mutual exclusive sub events. Okay, I hope you're having a basic intuition about all these assumptions, probability axioms. Okay, so we have a non-negativity, means like the probability cannot be negative, and we have a normalization out there, means like how we gonna normalize that, and how we gonna add that, and the output must be like 1. And we have additivity, and how these gonna union like a two mutual exclusive events, and how these finite and countable additivity, right? So I just want to give a formal probability example, so that it's easy for you to recapitulate what I have said till now, like from the probability introduction to this second lecture. So like the example look like, so me and my friends are participated in a election, which are held in a college or a school. Okay, so me and my three friends are just participated in the election in our school or college, and the A, B, and our names are the A, B, C, D, and the A has a 20% chance of winning, and the B has a 40% chance of winning the election. Okay, so these are the disjoint events. So if A wins, then these three are losses. If the B wins, these three will lose, and the C wins, and these three will lose, and the D wins, these three will lose. Means, right? I hope you're having a basic intuition about this. If one wins and the three are lost, right? So these are independent events, means they cannot occur both time. They cannot occur in a both time, like, so they cannot win two, means like the two cannot win in at the same time, right? Two cannot win at the same time. I hope you're having a basic understanding like what I'm saying, what are the disjoint events. So the probability of A or B, means like A is having a 20% chance and a 40% chance of a B of winning election, means like we are. So I just want to find these two which are independent variables. So we have seen the additivity rule, right, in that example. So we just simply A or B, we just simply union that. So we just simply union that 20%, we simply union that this A and B, and we will get our output. So we have a probability of A which is equal to, there is a 20% chance, right? So we just simply write 20, or what can we write, like 0.2 and a 0.4, which is equal to 0.6. That is nothing but equal to the 60%. That is nothing but equal to the 60%. The probability of A, which is equal to the 20%. So in a basic sense I have written the 20%, but in our formal way we used to write 0.2 and a 0.5, which is nothing but this 20 and 40%. But in our previous lecture we have discussed, right, the probabilities must be 0 and 1, right? So as of now just we are going to follow this pattern. So as of now we're going to, so I just want to give an example like how we go on, right? So as of now we're going to follow this pattern, 0.2 and 0.4, 0.8, etc. So the probability of A, which is winning, the chance of is 20%, and the probability of B, which is having a chance of a 40%, right? So we just given, right, we just written these two, and we have added these two, and they have a 60% of chance winning the election. Means like these two, means like there is a 60% of chance winning this A or B. I hope you're having a basic understanding like what I'm saying. I hope you're having a basic understanding what I'm saying. So until now we discussed some of the terminologies over there. We have discussed the sample space, and we have discussed the sample space, and we have discussed the events, and we have discussed the degree of belief, what is degree of belief, and we have a probability axioms, what are the non-negativity, normalization, additivity, and in additivity we have finite and accountable additivity. And I have given a formal example so that it will be easy for you, like what we are, so how we gonna use a probability in our real life example, and how these relate to, we are saying that there is a 60% of chance, means like there are people who bet on the students, like, means like the Tarak win the elections, this is 1,000 rupees bet for me. The Tarak will lose the election, this is 1,000 bet for me. Means like they have a 60% of chance like winning Tarak, and a 40% of chance like losing the election, right? So the probability has a lot of uses, there is a lot of usage in our daily life. If you clearly observe, there is a lot of usage in our real life. So I just want you to explore it on your own, so that it will be easy for you and as well as me, so that it will not be like a spoon feeding to you, each and covering each and every topic. So I just want you to explore it on your own, so it will be easy for you to understand and to remember, further, like, in your future. So I hope you love this lecture. So until then, bye bye, see you in the next lecture.